On the set of X is low, this is an August 2019 exam, just for a quick reminder. For number 1, AB is dilated by a scale factor of 5/2 centered at point P. Which statement is always true? So remember, when we do a dilation, we know that it's going to be a figure that is similar, so not the same size, but the same shape. So anything with like PA, this distance here, and then A to A prime, that is not going to be the same length necessarily, unless it's like 2 to 1 or something like that. So this distance from P to A and P to A prime, or A to A prime, will not be the same. Is AB and A prime B prime, are those lines going to be parallel? Okay, we know they're not going to be equal. And then, am I going to multiply the larger line by 5/2 to get back to the original? So remember, because the bigger side's on top, it's going to get bigger. So the question answer is going to be number 2. So remember that dilations preserve parallelism. The lines will be parallel on the shapes, just that the side's length won't be equal and the angles will be equal. So choice 2 for that one. All right, and I'll do a little highlighted action there for our answers in case everyone looks through it later. Number 2, we have a parallelogram. So remember those properties we talked about. Opposite sides congruent, opposite sides parallel. Okay, in this case, it's talking about the diagonals. So remember, the diagonals are supposed to bisect. Now what that means is that they're going to have the same midpoint. So if you do a quick drawing for yourself, just so you can identify what the point should be and what lines are going to connect the midpoint, start with the letter and then you go around in a circle labeling the others. So CD and then EH. And it doesn't matter which direction you go in. We're going to be talking about CE and then DH and where they cross. So all we have to do is find the midpoint of one of those two and we'll have our answer. Midpoint, remember, is average. Okay, so if we do the midpoint of CE, okay, it's going to be -5 for the x's plus the x for E, which is -1/2, and then 5 for the y plus the y coordinate on E, which is -1/2. Also, just a quick reminder, you have graph paper all the way at the end of your test. Okay, it's on the very, very, very last page, second last page, I should say. The last page is going to be your formula sheet. Okay, so this is the very last page. When you get your test, immediately tear this out, tear the graph paper out. You can fold it like in half and half again, and then you can make a quick graph here. So if you graph the points, you can also read them on there as well. All right, so just a quick reminder about graph paper and formula sheets. Yeah, get up there. All right, let's get back to it. So -5 plus -1 is -6/2 is going to be -3. And then 5 plus -1 is 4/2 is just 2. So the point is going to be -3/2, and that is choice 3. All right. Question number 3. We have ourselves a directed line segment question. So the coordinates of endpoints Q and S are given. Point R is somewhere on the line, so the ratio of the line from QR to RS is 2 to 1. So remember, we talked about doing that little tape diagram. There's one part on this side of the line and 2 parts on this side. So that means we're doing a ratio of 1 to 3 total parts, so we're 1/3 of the way up. And then we're going to count the rise over the run. So if we go from -9 to 9, that's +18. If we go from 8 to -4, we're going down and then 12. Okay, so we just need to figure out what our change in X is going to be. We're not moving the entire 18 points. We're moving 18, or you're moving 1/3 essentially of 18. So you remember you're multiplying that fraction of the line times the actual change in X, which gives us 6. And the change in Y is 1/3 of -12. -12, which is negative 4. So we are going to go back to the original point we started with, okay? Because we're 1/3, we're closer to that first point. And then we're doing negative 9. We're adding 6 to this coordinate. And we're taking 8, and we're adding negative 4 to this coordinate, or subtracting 4. And so we're going to get the point negative 3, 4. And so that's going to be choice number 3. Now you also have, if you guys remember, you also have graph paper back there. So if you get stuck, you can always remember, draw your graph or use your graph paper. Do a quick graph those 2 points, count the rise and the run, and then just remember you're moving 1/3 of the way down. You can figure out how far to go from there. All right, the altitudes of the triangle meet at one of the triangle's vertices. So think about the altitudes. Altitudes are the lines creating our right angles. So if the altitudes of our triangles, right? So if we make let's make our 3 triangles. The options are a right triangle. That was supposed to be an eraser. So if we make a right triangle, do the altitudes meet at one of the vertices? Now, the altitude of this side right here, right? The altitude of this bottom side is this side. This is the altitude from the opposite vertex perpendicular to this. Okay? If we think about rotating this triangle and standing it up, this side right here, right, is also the altitude of that opposite side. And then the altitude of the last side, we would draw, like, cut this way, and it's going to connect to this vertex. So these 3 altitudes all meet at that vertex, this point of the triangle, which is across from the hypotenuse. So that would be our answer. Now, if you're doing kind of a drawing shapes, if we look at an acute triangle, right, this would be one altitude, that would be an altitude, this would be an altitude. They're going to meet inside the triangle, but not on the triangle, okay? So it's not going to meet at the vertices. If we look at a obtuse triangle, one that's super stretched out like this, okay, this point, in order to be perpendicular, actually would be meeting somewhere outside the triangle, somewhere way over here. So when it's an obtuse triangle, your altitude is actually outside the triangle. Okay, and then this would be here, so it would be something like that. And if it's equilateral is the same thing as acute, so this would be inside as well. So choice 1 would be right triangle would be correct. Outside, right obtuse triangle, inside, equilateral triangle. Okay. Number 5, we have a median. Remember, that is this line right here that cuts through the middle of the opposite side. So it tells you that AB is congruent to DB, okay? And because it's a median, AB is also congruent to BC. All right, so we have 2 isosceles triangles at work. We have this isosceles triangle over here with those 2 sides equal. And we have this isosceles triangle over here with these 2 angles equal at BDC and BCD. So if DAB is 32, DAB 32, that makes this angle 32. Together that's 64. So this angle right here is the exterior angle. So this has to equal the sum of those 2. But if you didn't know that, you could get at this angle here by doing 180 minus 64. Okay, so this is going to be 116. And then you can get this 64 from subtracting from 180 that way. And then angle BDC is the angle that's right up here. Let's do that in a different color. All right, right up here. And so remember, we're going to do 180, take away the 64, and then divide by 2 since there's 2 congruent angles. We already know that this is equal to 116. So half of 116 is equal to 58. All right. On to the next one, number 6. Okay, this one we can do on our calculator. So I'm just going to pull up the calculator again. We're going to go to the graphing page. And then remember to get our equation that we want up, because remember, this is in that form. Now, we're going to hit Menu, and then we're going to smash the 3 button. So graph entry edit, equation templates, circle, and then choice 2 is our standard form, which is right here. Now to put the equation in that standard form, oh, we broke stuff again. Just menu, 3, 3, 3, and then 2. Now to put it in that form, notice that everything has to be on one side of the equal sign. So we're going to have to take this equation, we're going to have to rewrite it, okay, by moving over the 8x, adding the 6y, and subtracting 39 to get this thing equal to 0. So x squared plus y squared minus 8x plus 6y minus 39 is equal to 0. Now I can go type those numbers in. So for x and y, I'm going to put 1. All right. Where it says x, notice it's negative 8x. So we're going to go ahead and press the minus and then 8 button. Then we can arrow over to the next spot. It's 6y. Okay. And then the last one is negative 39. It's always plus sign, so you just have to press the negative if you're really doing like a minus there. And we'll hit enter, and it's going to graph the circle. So remember, we can pull up a grid. We can read these easier by going to Menu, View, Grid, and then Line Grid. And now we can easily see what the radius is and the center. So the center is the point 4, negative 3. And then we can count 1, 2, 3, 4, 5, 6, 7, 8 units over. So 4, negative 3, and the radius is 8, not 64. Remember, that would be if we plugged it into the equation, and then we have our answer. Now, real quick, let's actually go over the correct way to do this, in case it comes up later or on part 2. And that would be that instead of moving the 39 over here, okay, we want to get this in the x's grouped together and the y's grouped together and then complete the square. So we're still going to move over the 8x and the 6y, but it's going to be x squared minus 8x plus y squared plus 6y equals 39. And then we're going to do our b over 2 squared to both sides. And this is going to help us complete the square. Now remember the 3 amigos. We have the b over 2 squared, okay, which when we plug in, for the x's, that's negative 8 over 2 squared. The next amigo here is when we do the division, we get negative 4 squared. And negative 4 squared is 16, okay? So we are going to have to add 16 to both sides of the equation in order to do this. All right, now this middle amigo is what actually goes in the parentheses here. Okay, but the 16 is what we add to both sides. So we're going to put a plus 16 underneath the negative 8x and put a plus 16 over to the 39. Then we repeat that process, this time with the b term for the y's. So 6 over 2 squared is 3 squared, which is 9. And then we're going to add 9 to both sides. Okay, so now we can rewrite x squared minus 8x plus 16 plus y squared plus 6y plus 9. And then we're adding 25 and 39, which gives us 64. So now we can regroup and draw this as a quantity squared. Remember that number that was in the parentheses before we squared it is going inside. That's the b over 2 part. Plus, what do we do with the y's? So remember our amigo over here is 3, so x plus 3 squared is equal to 64. And then remember when we read the equation, We change the signs. So the center is the point positive 4, because it was negative, so we change it. And then negative 3. And then the radius is equal to the square root of 64, and that's d8. So that's just a quick recap on completing the square to create this equation of the circle. But remember, if it's multiple choice or even a part 2 question, you can get a point just by using your calculator, pulling up that equation template, and then using the grid to read your points. Okay, number 7. So we're going to go ahead and label everything we can, and then we're going to identify what the measure of EFA is. So first of all, important parts when you're reading, it's a parallelogram. Okay. We have CF bisecting angle DCB. So let's mark that down. So DCB, this angle is getting cut in half. We also have DG bisecting ACD. So that means this angle is also getting cut in half. And then these two lines are just intersecting at E. So if angle B is 75, keep in mind, what are we trying to find? We're trying to find angle EFA. That's this angle right down here. Okay, so that angle is connected to a triangle right here. So can we use this triangle to help us out? Right? That seems like the logical choice. And the answer is yes. Also, remember, in a parallelogram, the angles that are next to each other, the adjacent angles, add to 180 degrees. So that tells me that this entire angle up here has to add to 180 with 75. So 180 minus 75 is going to be 105. That's the measure of this entire angle right here. And then we cut it in half. So 105 divided by 2, okay, is going to be 52.5. And that's the measure of the angle that's down inside the triangle there. Okay, so the exterior angle theorem just says add these two up, and that's the sum of this one. So that's one way to do this. So 75 plus 52.5, we can add a 0.0 if you want, is going to be a half. This is 7, that's 12, that's 127.5. There's our answer. Or if you weren't sure that you could do that, or if you forget, remember we can find this angle first and then just take away from 180. So we already know that adding these two gets 127.5, which is the sum of this. That's not that angle. Don't put that there. That doesn't go there. That was a mistake. 180 minus 127.5. There we go. Okay, so we can add the 0 here. We're going to borrow some stuff. You know what? Yeah, we're good. I feel like we did something. No, we added there. Okay, going backwards here. For this one, we're going to have to borrow. That's why I was looking over here thinking I had to borrow, but I added, not subtracted. Okay, at this point, just really, keep it simple here. Let's just use our calculator. Okay, so open up a calculator page. $180 minus 127.5. We're getting 52.5. We should feel like we should know that. And then take that away from 180 to get 127.5 over here. Okay? All right. On to the next one. What size equation line that is perpendicular to the equation who's given? All right. Now, nice and easy. If you have a calculator, remember, you can open up a graphing page. So we'll go new document here. No, we don't want to save. We want to open up a graph. We're going to delete the equal sign, and we're going to choose relation. That lets us type in any equation we want. We read the problem as 2y plus 3x equals 1, hit enter. It's going to graph the line. We're looking for one that's perpendicular to that one. Now we can get an idea of what's going to be really close just by typing in our answers. So 2/3 x plus 5 over 2, we can press tab. Okay, so 2/3 x plus 5 over 2, hit enter. Oh, it doesn't like certain things. What did it say? Oh, we didn't have a y equals. Silly Mr. Z. Y equals. There's that line. That's pretty close. And then we can go for the next one. So negative 2/3 x plus 1, tab, y equals negative 2/3 x plus 1. Right, that's not perpendicular for sure. That one's out. Okay, we have 3 over 2x plus 2. So tab. All right, that is definitely not perpendicular to the blue line. And our last one is negative 3 over 2x plus a half. So tab y equals negative 3 over 2x plus a half. And we can definitely rule that one out because that is on top of the line that we just got, right? That's right on top of it. Same line. So the best answer based on what we can see, what we're reading, would be the red line, which if you press tab, you can go back up and it'll actually highlight it as you go. And we can see it's that one right there, 2/3 x plus 5 over 2. All right, let's actually do it real quick. So take the line they gave you. We're going to solve for y to identify the slope. So 2y plus 3x equals 1. Move that 3x to the other side by subtracting. 2y equals negative 3x plus 1. And then divide by 2 to get our answer. All right, now our slope is negative 3 over 2. That means that a perpendicular slope has to have the opposite reciprocal. It has to be positive 2/3. So that is the only slope that has positive 2/3. So that is going to be our answer. All right, that's it. Number 9, which sequence of rigid motions will prove the triangles are congruent? Charlotte, what do you got? Yep.
Find the y-intercepts for these types of questions.
You're not going to need to, because it's just asking for which one's perpendicular. So the y-intercept is not really of a significant matter. It just has to have the opposite slope. Because theoretically, let me escape out of this. You know, if I could move this line around, right? If I slid the line up this way, it's still going to have the same slope. It's still going to be perpendicular. Even though it's going to move, the y-intercept's going to change. Does that make sense?
Yeah, thank you.
No problem. So it's just the slope we're paying attention to, not the whole thing. Welcome, Matt. We are taking a look right now at question number 9. I taped the other one, so I'll post those ones when we're done. You can go back and take a look at them. All right. Triangles are drafted on the axis below, which is going to show that these are congruent. So remember, reflection of the line y equals x. The rule is you just switch the coordinates. And also the line y equals x, it just goes right up through like 1, 1, 2, 2, 3, 3. So it's going to be this line right here. Okay? So imagine taking your pen and like folding it over that line. This point C is going to go here, right? Or here. So it's not going to be where T is. So that's not going to work. All right? We can rule out number 1. Also, keep in mind, when you're looking at the points here, right, that A is supposed to go onto R and B is supposed to go onto S. So if we just do a reflection, that's not necessarily going to work. We're going to have to do like 2 reflections. So if you take a look at the next one, what if we rotated 180 degrees around the point 1, 0? So here's the point 1, 0. Now, the easiest way to do this rotation is to kind of treat this like the new x-axis. Okay? So pretend like this is my new x, and then that's the y. So when I look at this point and I rotate it, right, 180 degrees around, this point is going to go around here. It's left to, up to. So it's kind of like saying that my point is -2, 2. And when I rotate 180 degrees, it's going to become the point 2, -2. Now that means it's going to go 2, -2. It's going to go right on top of t. So you can kind of see if it goes around that point, and I treat this new line like the x-axis. My screens are freaking out right now, so there we go. Coming back. Okay, that C is going to go right onto T, that B will go right onto S, and A will go right onto R, because it's like going down, right? How many units? 2, 4, 6, I think it's 7? 2, 4, 6, 7 over 2. So if we go down 7 and over 2, that'll be the point we end up on. All right. We can also use some process of elimination here. So this, by the way, is our answer. I'm going to have to close this down for a second. Open it back up. It doesn't like me right now, but it's okay. We'll get there. Very temperamental. Okay. So that's why we know the answer to that one is going to be all right, that guy right there. Now we can go through and eliminate the other ones. So if we take a look at a line reflection over the x-axis, right, that's going to move me here. And this triangle right now is pointing in the wrong direction. So if I just, oh, it should be down one more. It should be down right there. All right. So now if I just slide it over 6 to the right, it's facing the wrong way. So that's not going to work. And then if I reflect over the x-axis, and then here's the line y equals 1, okay, is this going to work? So, oops, this is x equals 1. That would work, but that's not what it says, is it? It says y equals 1. Y equals 1 is horizontal line right there. So if we do that, it's actually going to move it back up here. Okay, back up there, just not, that side's too big. All right, not going to grow. But you guys get the idea. All right, so it's like 1, 2, 3 units away. 1, 2, 3 units on the other side. It's going to be right there. All right, so that is also not going to work. So we're kind of stuck with picking choice 2 because of the other ones just aren't feasible. Number 10, okay, scale factored at the origin. What I would recommend once again is go pull out the graph paper from the very second last page. You should have already torn it out when you started. You can graph your line. Also, what we can do, okay, remember it's 4 units from the origin. So the key thing here is if the origin, which is the center, is on the line, okay, the answer is the same line. All right. Now, if the origin is not on the line, it's going to be parallel, okay? And the y-intercept gets multiplied times the scale factor times 4. So same slope, y-intercept times 4. So all we have to do is, once again, grab our calculator. Let's grab a new page here. We're going to delete the equal sign again if we need to. Just click relation, and then we can type in exactly what we see. Y equals -1/4 x minus 2. This way we don't have to solve for y. We just type it in and hit enter. There's the line right there, okay? Now, remember, this is not on the origin. It doesn't pass through the origin. So it's going to shift down. The distance between the line and the center is going to get multiplied by 4. So instead of being 2 units away, it's going to be 8 units away. and it's going to be at -8, okay? So the slope of their line was -1/4. Our slope has to also be -1/4, so we can rule out these two. And we know that the y-intercept is going to get multiplied times 4 because the center is not on the line, so we're going to choose choice number 1. So if the origin was on the line, right, that means the center was on the line, we would have picked 2. But since it's not on the line, we have to multiply that times 4. Number 11, square has a side length of 7. Which three-dimensional object is formed by continuing rotating square MHCH around side AT? So just draw a picture, okay? We have a square. We're going to call M. That's not an M. That's M. A, TH. So if we rotate this around AT, so AT is going to stay still. This is like our axes. This shape is going to get reflected over to the other side. Okay? And then we're going to trace the path the vertices take. So the vertex is going to go around in a circle here, and we're going to get a cylinder. Now, because the side length is 7, that's the radius, and the height is also 7, but the diameter is double that, that's going to be 14. So not a diameter of 7, okay? And it's not a cone, it's a cylinder, so it's going to be choice number 4. Okay? Number 12 is next. Once again, we have the measure of the central angle is 120. The area of the shaded sector. So since we're doing the area of the shaded sector, we want to talk about that angle over here. So that's going to be 240. And then we're going to do, remember, the area over pi r squared, the area of the circle. So area of the sector over the area of the circle equals the angle of the sector over the angle of the whole circle, which is 360. And then we're going to cross multiply and solve. So x over pi times 9 squared is equal to 240 over 360. So x over 81 pi. We can type 240 over 360 in our calculator. It'll spit out 2/3 for us. And then we're just going to cross multiply to solve. So we're going to get 3x. 81 times 2 is going to be 162 pi. And then we're going to divide by 3 to get our answer. Since these all have pi's in them, I'm just going to divide the numbers, okay? 162 by 3, and then it's going to be 54 pi. Now be careful, because if you didn't use the 240 and you use the 120, okay? So if we did 120 over 360, we cross multiply, okay? So instead of getting, this turns into 1/3. So we're going to get, right, 3x to equal 81 pi. And when we divide by 3, we're actually going to get 27 pi. 27 pi is one of the answers. So they already know the mistakes that most people make. So those mistakes are going to show up. So double check when you're done, okay? Double check when you're done that it says shaded area. Make sure you use the angle from the shaded area and not the angle from the unshaded part, okay? Remember, these are like gotcha questions. They know you're going to make this. This is the easy mistake to make. A lot of people make it. So one of the answers is that mistake. Don't fall into the pinhole there, okay? 13, quadrilateral has diagonals are given, which are going to prove it's a parallelogram. Draw a little quick picture for yourself just so you can identify those diagonals. So QR, well, we don't call it QR. We call Q, and then RST, go around in a circle. So QS and RT, okay, intersect at M. And then what should happen, right? TQR, which is right here, is that going to be supplementary to QRS, right? That's definitely not going to be true because those aren't the entire angles. Those are just one part of that angle. It should be TQS and then QRS. So that's not enough. Okay, so number 1 is out. What about QM being equal to SM and then QT and RS, right? That's not enough. Either both diagonals have to bisect and be equal or both opposite sides, not one set of each. So that one's out. QR and TS. What about these two sides equal and then QT and RS? That works, right? Opposite sides are congruent. So that works. Okay. And then the other option would be choice 4. Once again, if you're labeling for yourself, we have QR and TS equal. We would need these two sides to be parallel, but it gives you the other two sides. So it's not one set parallel and one side congruent. It's the same set equal and the same set congruent. So that one's also going to be out. So choice 3 is going to be our answer. Okay. It doesn't want me to pick that, but we need a highlighter, people. Oh, all right. What do you know, like? Awesome. All right. And so that's going to be our answer. All right, let's go to the next one. In a second. Okay. All right, we're not going to that one. Number 14, standard size golf ball. Okay. The diameter that's given. What material used to make the golf ball? Oh, the material weighs 0.6523 ounces per cubic inch. What is the weight to the nearest hundredth of an ounce of one golf ball? So once again, this is going to be a volume question. Okay. So if we're reading the volume question, let's make sure that we're in the same units. So we have inches, okay, and we have ounces per cubic inch, and we're dealing with ounces. So we're all good. We don't have to do any conversions. So now, since we're doing cubic inches, this is a volume question. And remember that a volume of a golf ball is a sphere. On the very last page of the exam is your formula sheet, so you can use that. It's going to be 4/3 pi r cubed. Okay. They give us the diameter is 1.680. So we just have to take half of that. First, we have to click here. 1.680 divided by 2. So that's 0.84. So we know that that's my radius. So now we're going to do volume equals 4/3 pi times 0.84 cubed. And we're just going to use our calculator. Because it says round, we're going to use the pi button. So we can do 4/3 pi, so pi button, r cubed. So if you want to put parentheses, that's fine. R we already got was that last question, so we can just bring that down. Hit the little caret there for the exponent to the 3rd power. Okay, hit enter. Make sure that this is the formula that we wrote down, right? And it is. So we get this answer right here. So let's round it. Let's write it out to about 4 or 5 places, just so we have that number to hold on to. But we're really going to use the whole thing when we do this. So 2.48 and then 271. And this is in inches cubed. And now we're just going to multiply that result times 0.6523. So up arrow to grab that whole thing times 0.6523. Just have to pull that number back. And then we round it to the nearest hundredth. So that should be 1.62. And this is ounces. So that is our answer. Now be careful on this one, once again, because if you use 1.68 instead of 0.84, guess what's going to happen? It's going to be one of the answers. .68, right, is this, times that same number, 0.6523. Oh, it's not even one of the answers. Crazy. Usually it is. Just be careful. We got lucked out that it's not here. So we would have known that something's wrong when we did something off. Once again, if you get stuck on a question, skip it, go to the next one. All right, Chelsea, sitting 8 feet from a tree. From where she is sitting, angle of elevation. Ooh, angle of elevation. That's a trick question. All right, so we got ourselves a tree. Tree. Okay, Chelsea is sitting 8 feet from the tree. Chelsea. All right, from where her line of sight is to the top of the tree, that's 36 degrees. Now remember, elevation is from Chelsea looking up. If there was a birdie at the top of the tree, looking down would create the angle of depression. These two angles are equal. We're always putting the angle of elevation or depression in that bottom corner down there. Okay? Now, here's the other problem. The tree, this line of sight is not the ground. Okay? The ground is actually down here because the grass is green down there. And it's 1.5 feet above the ground. So, what we need to do, okay, is know that this side is 8. We need to get this height of the tree, but then we have to remember that the entire height for the tree, from top to the bottom where the ground is x plus that 1.5 at the end. So, since we know it's going to be trig, we have a right triangle, and we're talking about an angle, that is going to be SOHCAHTOA, as opposed to Pythagorean Theorem, which is just side lengths. We label our sides opposite. We have their adjacent. Okay, so it's going to be our tangent. So the tangent of the angle, which is 36, is equal to the opposite side, x over the adjacent 8. We're going to cross multiply. Anytime we're looking for a side, we cross multiply. So 8 times the tangent of 36 is equal to x. Grab the calculator. Double check to make sure it says degrees. It's in degree mode. Okay. Trig. Ooh, before we do trig, we're doing 8. 8. Trig. Tangent. 36. Enter. We're getting that answer right there. So we'll write it out to a few decimal places. 5.8123. Okay, just checking on the battery power there. Now, it says nearest foot. Notice that 6, that would be 6, but that's the answer for x. Our answer needs to be x plus 1.5. So we have to add, right, that answer plus 1.5, and then now we can add, round that to the nearest foot, and that's going to be 7 feet, okay? So that is our answer. We'll write that down, by the way. So x plus 1.5 is equal to 7.3. 1, 2, 3. And so that's 7. All right, number 16, I'm seeing the triangle where we are cutting one triangle into 3 triangles. So it says altitude intersects the hypotenuse. That's another reason we know this. So we're going to draw out our 3 triangles. One big one, so A, C where the right angle is, and B. Okay, a medium-sized one that represents the triangle on the left here. So the right angle, once again, is down where D is. C is the short leg, and then B is the longer leg. Okay, and then we can go to the super small one off on the left. The right angle is still happening at D, short leg over to A, long leg over to C. And now we can go label our sides. This is one of the reasons if you bring colored pencils, it makes it a little easier to do. So if we have AD, so AD is this side right here, over AC, well, okay. So now we're going small to really big. That means we got to stay consistent. So if we switch colors here, CD, that's this side right here, over BC, and hey, look at that works. Okay, that works. That's true, right? Small to big, right? Small to big. Okay, so that would work. So that's an option. Double check that it says always true, not just not true. Okay, but let's go ahead and let's go through the rest of these. So I'm going to undo that. We'll keep this highlighted. All right, so what if we'll do blue here. AD over CD. So AD is here, okay? CD is the side right across from it. So we're talking about the left to the right. And then we're doing BD over CD. And BD is going from right to left. So one's left to right, one's right to left. That's not going to work. Okay? And if we go to the next one here, we have AD, oh, we did that one. AC over CD. So AC, that's this side right here, over CD. So we're going from big to medium. And then we have BD over CD. And you can see that once again, BD is here. That's not even down. That's down there. That's the wrong triangle altogether. Okay? So that doesn't work either. And then we have AD over AC. So AD is here. AC. So we're going from small to big. And then we say AC. Ooh, where's there an AC? Oh, that's hypotenuse, right? Over BD. And BD's here. So that's not going to work either because that's in the wrong figure. That should be CB. So that's how you can kind of go through and look at those figures and figure out which one's going to work, which ones aren't. Okay? So choice number 1 works because the corresponding sides from those triangles are in the same position and they're in the same order. 17, we got a countertop. What is the dimensions are shown? Okay. 18 inch, 21 inch. Square foot. We got a problem here, right? We're out of units again. Okay? So we're going to need to do some conversions. Remember, to get from inches to feet, we just divide by 12. So 18 divided by 12 is going to be 1.5. And then we have 21 over 12. Not as nice. Now it's 7/4, but if we, instead of hitting enter, hit control enter, it'll give us a decimal if it can, and it's 1.75. So we'll use that instead. And this is in feet. Okay, so countertop is modeled below. We know that this side is 1.5, that this side is 1.75. All right, this section is going to be removed for the installation of the sink. What is the area of the top of the installed countertop? Now, we're removing this. So remember, we're finding the area essentially of the shaded region here. So we need to find the area of this whole thing and then take away that piece. So easy way to do it. We can kind of think about splitting this into 2 separate rectangles. So it's 8 feet this way by 2 feet this way. And then this one, because this is 2 feet here, that means this is 3 feet down here. And this is 3 times 2. So 3 times 2 is just 6. So 6 feet is the area of this part. And then 8 times 2 is going to be 16. So the area of the whole thing is going to be 16 plus 6, which is 22. Okay, so that's the shaded area. We'll do shaded so we can tell what's going on. Now we need the unshaded part, okay, where the sink is. And the area of the sink is just going to be 1.5 times 1.75. And then we got to subtract those 2 things. So 1.5 times 1.75 gives us 2.26 or 625, 2.625. And then we're just going to subtract that away from 22. So 22 minus, highlight our answer, bring it back down. We get 19.375. It did say the nearest square foot. Since it's 19.375, that's going to be 19 feet. Okay. have our answer. 18. We got some points connected. Okay. So B and C. And the diagram below. BC connects these 2 points, which are on congruent sides of isosceles triangle ADE. So we know that these 2 sides are equal. All right. Such that a triangle ABC is isosceles with vertex A. Now, because these 2 triangles are isosceles, that means that this is a side splitter theorem because we're cutting these 2 sides proportionally, okay? So that means that this side is parallel to this one and these 2 triangles are similar. So we're going to label, we're trying to find the length of BC, so just remember that. So that's X. We know AB is 10, okay? That BD is 5, that DE is 12. So we're going to think about this as being 2 separate triangles here, okay? So let's not highlight that one. We got this small triangle right here, and then this side that's 12 is part of this really big triangle going all the way around. And so in order to do this, we're going to have to compare the left side of the small triangle to the left side of the big triangle, which is 15, the small side of the bottom side of the small triangle to the bottom side of the big triangle. So 10 over 15 is going to equal X over 12. And you could have done like 10 over X, 15 over 12 would have been fine. As long as when you cross multiply, you're going to get 15X is equal to 10 times 12, which is 120. Divide out by that 15 here, and we're going to get our final answer. So 120 over 15 gets us 8, and there is the length of BC. And because we called, double check it, because we called BC X, and that's what it's asking for, we know that's the answer. All right, 19. We got another right triangle, which must be true. Remember, anytime we're talking about our 2 angles here that add to 180, the sine of one is equal to the cosine of the other. So that's an easy catch, okay? Sine of one is equal to the cosine of the other. Not tangent, not sine and sine, and not sine and cosine, but with the same angle, okay? So just be careful. So anytime angle A plus angle B is equal to 90, the sine of A is equal to the cosine of B. Or vice versa, the cosine of A is equal to the sine of B. All right, we got another right triangle without a picture, so let's draw it. And the big thing is, what is the right angle? What is the hypotenuse? So the hypotenuse is RS, and that means the other letter, which was T, is our right angle. We have an altitude drawn, so we're drawing a line down to V, okay? Oh, we got our little 3 triangles going on here, interesting. So if RV is 12, and RT is 18, what is the length of VS? So this is where we're going to have to do a little bit of work. And because we're drawing our triangle and altitude drawn to the hypotenuse, we know we're doing our 3 different triangles here. So I'm going to do these just below the shape. So here's the real big triangle. Now this side all the way in the bottom is 12 plus X, and this side over here is 18. And if you want to label RTS, go for it. In the medium triangle here on the left, right, we have our right angle at V, short leg at T, long leg at X, S, and this is VS. That doesn't match with anything over here, so that's kind of out. And then we have our small triangle, still with a right angle at V. We have the short leg at R and then at T, and here we have RV, which is 12, and then the hypotenuse is 18. And when you look, we can see that these sides here are corresponding to those 2 sides, and so now we can make a proportion. So 18 from this triangle right here over the corresponding side of 12 is going to equal the 12 plus X over the corresponding side of 18. Cross multiply. So we get 144 plus 12X is equal to 18 squared. I think that's 324. is take away that 144. So 12x is going to equal 180, and then we're just dividing that answer by 12 to get our answer of 15. All right, and that is how we're doing that question. 21, the volume is given for a square pyramid. It's centimeters, centimeters, and centimeters. We don't have to worry about anything. Okay, so remember the pyramid. All right, is given. Now, the edges are 64 centimeters long, and it says the slant height is 40. The volume, though, if you remember, doesn't use the slant height. It uses the whole height, going all the way down. We need the height down the middle here. So this is creating a right triangle where it's 40 and 64. We need to get the height first. Remember that we're going to cut this side in half to make 32. So we're actually using oh no, there we go. Feedback in here. Okay, so we're really talking about a right triangle here with sides of 32 and a hypotenuse of 40. We need to figure out this first side, this height first. So we're going to do 40 squared minus 32 squared is equal to 8 squared. You can just use the calculator here. 40 squared. Oh, that's okay, Justine. Glad you got back in. Minus 32 squared is 576. And then we're going to square root that. So we'll just do that right now. Go up, grab that answer. And it's 24. Okay? That's not the answer, though. That's just the height. All right, so 576, we're going to square root this, is equal to h squared. So we're going to get 24 is equal to h. Okay, now that we know that this is 24, now we can do the volume formula. That's 1/3 the area of the base. The base is a square, so it's going to be length times width, or side squared, side times side, and then times height of the whole thing. So 1/3, 64 times 64, and then times our 24 that we got for the answer there. Okay, so just want to show something real quick. 64 times 64 times 24 is 98,302, okay? And then we're doing 1/3 of that, so 32,768. And there is our answer. All right, and if you didn't solve for the 24 and you used 40, right, 64 times 64 times 40, and then that divided by 3, that divided by 3, Control Enter. Okay, 54,613, that is that answer right there. So they're banking on people using the wrong number there. All right, almost done with part 1 here. So once again, which relationship must be true? Remember, anytime we have the chords intersecting, it's the part times part for each chord that we're multiplying together here, okay? So it should be PT times TQ, okay, is equal to RT times TS, okay? So PT times TQ, RT times TS, not plus, and we don't know that those are equal. It should be choice number 4. All right. Okay. All right, we're back. All right, 23. The rhombus is graphed below. Which transformation would carry it onto itself? So we would want to end up with the same shape back we're done with. So if we rotate 180 degrees about the origin, right? Not going to work. If you flip your paper upside down, right, it's going to basically end up like this. Okay? That's going to be the shape we end up with when we rotate 180. So that's not going to work. All right? If we reflect over the line y equals 1/2 x plus 1. Now, 1/2 x plus 1 is here. It goes up 1 and over 2 to the right, down 1 over 2 to the left. That's this guy right here. Now, the question is, when we reflect over this line, is this going to match up onto itself? We fold over that line. Okay? So maybe, let's take a look at the line y equals 0. Now, y equals 0, if you remember, is the x-axis, right? That's this guy right here. If we fold over that line, that is not going to work, because remember, this part's going to go down here. That's going to end up down here. That's going to up here. That's going to up there. We're going to get that same shape we got the first time back. So that's not going to work either. Okay. So what about the line x equals 0? Remember, x equals 0 is the y-axis. And if we reflect, this point, which is 4 units to the right, goes 4 units to the left. This point's going to go back over there. These sides are going to map onto each other. That's cutting it right in half. So this will carry it onto itself. That is the best answer to pick. All right. If we do the other one, though, right, we get this line. Okay, so if we fold over this line, the problem is that this point here, I don't know if it's going to go directly on that point. So, but the best answer would be cutting it right down the middle this way. So that's why we're still going with this line, x equals 0. That is the y-axis. And y equals 0 is the x-axis. Just keep that in mind. They're trying to trick you a little bit there. Okay? And I'm trying to think here. Here's why. The line that it's going to reflect over is going to be perpendicular to this one. So the slope of this line, right, is down 1 over 2 to the right. That's negative 1/2. But the slope of this line is positive 1/2. So the actual slope that we want that's perpendicular is going to be negative 2 over 1, not negative 1/2. So that's why it's not going to map on. It's got to be the perpendicular slope. 24. Ooh, we got a little ladder against the wall. This is looking like a trick question based off of what we know. So ladder coming off a wall here. That's supposed to be those rungs of the ladder. All right, makes 65 degrees with the ground. So that's 65 degrees with the ground here. What is the horizontal distance from the wall to the base of the ladder? We know that the ladder is 15 feet long. The horizontal distance is going to be this distance down here. So once again, find our angle. We got adjacent. We got hypotenuse. We got some SOHCAHTOA. And we are using adjacent hypotenuse. So we're going with some cosine, a little loosey-goosey with that circle there. So cosine of the angle, which is 65, is equal to the adjacent, which is x, over the hypotenuse is 15. And then we're cross-multiplying. So we're just doing a little 15 times the cosine of 65. That's 6.33, it says nearest tenth, so 6.3 is going to work. And they have ourselves an answer. All right, moving into part 2, 3, 4, here we go. In the parallelograms shown below, what is the measure of angle B? And then we have to explain why. Now remember, it's a parallelogram, so key thing here that's going to help us out. We have opposite angles congruent. So with this angle and this angle are going to be equal. Okay, and then the angles of a triangle make 180. So we can kind of do some work off to the side just to figure out what the measure is. So 98 plus 36, this is 14, carry the 1, this is 134. And then 180 minus 134, that's like 150, but 4 less, so that should be 46, right? And then I'm getting a little tired here, we're just going to double check here. 98 plus 36, 180 minus. All right, we're good. So we know that this is going to be 46 degrees, which means angle B is 46 degrees. So we have to say the measure of angle B is equal to 46. It said explain why. So we can say since opposite angles in a parallelogram are congruent, and the angles in a triangle add to 180 degrees, the measure of angle D is equal to 46 degrees, and the measure of angle B is also going to equal 46 degrees. This is fine. If you wanted to, for example, just get a little bit, let's say, rearrange some of this, what you could say is that since the angles in a triangle add to 180 degrees, okay, we'll switch to red here. All right, then, right, 180 minus 98 plus 36 is equal to 46, okay? And since angle D is equal to angle B, we can say opposite angles in a parallelogram are congruent. All right, then angle B is equal to 46 degrees. But the key thing is we've already shown our work up here. So we're just justifying this last statement here, okay, by saying what we just talked about. The opposite angles of a parallelogram are congruent, and the angles of a triangle add to 180 degrees. Then we know what the measures are. So both of these would be appropriate based off the work and then the writing. Just two different ways to get there. All right. Let's take a look at number 26. Airplane took off, reached an altitude of 5 miles. What is the angle of elevation? So key thing here, angle of elevation. Now, miles, and nearest tenth of a degree. So as long as we're in the same units, we can do this. Our angle is located down here, the angle of elevation. We find our angle. We can call this x. We label our sides. This is opposite and hypotenuse. We know we're doing some SOHCAHTOA. So we now know that we can do the sine of the angle is equal to the opposite 5 over the hypotenuse 25. And that means in order to get rid of the sine, we have to use the sine inverse. So anytime you're looking for the angle, you're going to use the inverse. Those are going to drop out. And then we're doing the sine inverse of 5 over 25. Okay, calculator time. Trig, sine inverse, 5 over 25, 11.536, I'll say 6, we'll say 7, 11.5, and we want nearest tenth. So x is approximately nearest tenth, 11.5, and this is degrees since it's an angle. And we're done. 27, okay, we would need to describe some rigid motions. So remember, we want to look to see what is pairing onto what. So A is going to go onto D, C is going to go on to F, and B is going to go on to E. So it looks like we're just doing a rotation or a turn. Okay, option number one, we know that D, if we rotate, right, we can talk about how to get these points to overlap first. So if we think about, we want A to end up on D. So if we translate A to D, that means we have to go down 2 and then over to the right. 1, 2, 3, 4, 5, 6, 7, 8. So that'll be our first move. So we're going to say first, translate triangle ABC. We have to go ABC onto DEF. Okay, and we can use our directions here. So down 2 and left, right. All right. This thing is stalling out on me here. Right. And we can count 1, 2, 3, 4, 5, 6. Okay. Now our triangle is going to be located here. And now we just got to rotate it, and we just got to turn it upside down. So go 300 or 180 degrees. So then we're going to say, then rotate triangle ABC 180 degrees. We can say counterclockwise if you want, but it's already implied when we say the 180 degrees. We do need to say what we're turning around. So we can say around point D, and we're done. Okay. Now there is a point that we can rotate around where this is going to work. And if you think about how would you redraw your axes, so where's the middle going to be between these, you might think to yourself, okay, if I made the middle right here, right? If I treated this like my x and y axes, this point is down 1 over 3, so down 1 over 3, it's going to map onto it. This point I'm going down 4, right? And over 3. If I go down 4 and over 3, I'm right onto it. So we can kind of get that to work. So this point would have to be the center. So we could do a rotation of 180 degrees, but we'd have to spin on the point 0, 2. So if you think about where you would put your axes, new axes to turn, that origin that you're spinning around, that would be the point, the center of rotation, if we got rid of the axes. So that's kind of a way to look at that. But either of these two things are going to work, okay, depending on how you want to write it. So if you can't tell what it is, think about moving it to overlap and then rotating around that common point. Okay, vertices are down below. Determine and state the area of the triangle. Now this is a part 2 question, so keep that in mind, that it should not be that difficult to do. So chances are that our triangle is going to be a right triangle, or that when you connect the sides, like the sides counting the base and the height are going to be like perpendicular to each other, meaning like they're going to be easy to count. You can just count straight left and right and straight up and down. I'm just going to bring this over here just for my purposes, okay? Because my page is not that big. So, -2, -1, 10, -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do we tell you guys, right? Perfect line going across, and then 4, 4. Okay, so the base and height we can easily count in order to do. The base is going over 2 and then 10, so that's 12. And the height is going up 1 and then 4, so the height is just 5. So the area of our triangle is 1/2 the base, which is 12, times 5. 1/2 of 60 is 30, and we're done. Now, if you don't have nice lines, you can just encase our triangle in a box, figure the area of the two rectangles or the triangles that are around it that are going to be right triangles. Okay, so you can count, right? 1, 2, 3, 4, 5. This is 6. This is 6, and this is 5. So these two areas are going to be 30 and 30. The whole thing is 120. Okay, or sorry, half of 30. So this area is 15. This area is 15. Okay, so the area of triangle 1 is 15. The area of triangle 2 is 15. And the area of the whole rectangle we know is already 60. So we just subtract 60 minus 15 minus 15. And that is another way for us to get 30. Okay? But if it's horizontal and perpendicular heights, just count them. All right, using the construction below, state the degree measure of CAD. So one thing we can notice is that this line at the bottom is in the entire length of AB, and they've essentially drawn the top of our football construction here. So, oh, we're lagging again. Still here, though. So, right, when we do our construction of the football, the top of the football, right, it creates an equilateral triangle. Because these are all the radii and they're all equal. And this construction, when we do this line here, then afterwards, right, with our x going through the middle, that is the angle bisector. That's a terrible line that we drew there, but you get the idea. So remember, the angle that was originally there was 60 degrees, and we've cut them in half, so these are now 30 degrees. Okay, so we say angle CAD is equal to 30, and then we can just describe. Triangle ACB is equilateral. All right. And line AD is the angle bisector of a 60-degree angle. And that would be enough. You can get into more specifics that this construction is creating an equilateral triangle and then bisecting the angle. But as long as you mention the fact that you have an equilateral triangle and an angle bisector, you're good. Okay, 30. I can already see circles with tangent lines. All right, we've done this question before. So if line arc LZ is 56, we want to find the measure of angle P. Remember, the measure of angle P is outside. Outside is different. So we're going to do the big arc minus the small arc and then divided by 2. So this key thing is that this is the diameter. So if this is 56, this arc is 180 minus 56, which is going to be 130, and then take away 6 more is 124. So if I follow the measure of angle P rule here, 124 is the big arc minus the small arc, which is 56, and then we're going to divide it by 2. So we grab our calculator, 124 minus 56, and then divide that answer by 2, gives us 34. And that's it. We're done with that one. Okay, 31, we have a water basin in the shape of a right cylinder. So right cylinder means that the height of the cylinder, we're going to be freezing again in a second here, I think. I don't know if your screens go all wonky, but mine just went black and black, so it's coming back. So cylinder, and the right cylinder means that the height here is the side length. Now, when we're reading, remember to focus on a few things, okay? Is it the same units? Are we doing, what are we trying to calculate here? So a large basin is the shape of a right cylinder. Inside the basin, the diameter is 8 a quarter feet. The height is 3 feet. The terminus date to the nearest cubic foot, so that tells me volume. Okay, the number of cubic feet of water it will take to fill to a basin a half foot from the top. Okay, this is important. So it's 8.25 feet is the diameter. Whoop, that went in the wrong spot. So that means this line is 8.25 divided by 2, which is 4.125. That's my radius. The height is 3 feet. But remember, we're only filling the water to a level that is a half a foot from the top. So the water is going to be filled up to here. So technically the height's not 3, it's 2.5 feet from there down. Okay? So the volume is equal to pi r squared h. That formula is on your formula sheet. You're going to tear off when you get your test in the back. We're doing pi times 4.125 times our height, squared by the way, times 2.5. And then we're going to the nearest cubic foot. So we are using our pi button. So pi times 4.125 squared times our height, which we said was times 2.5. Double checking, hit it. 133 point nearest cubic foot, so it's 133.6, so that means it's 100. We're rounding, so the volume is approximately 134 cubic feet, and there's our answer. Okay, a lot of ways to lose points in that question. If you use 3, if you didn't do half of 4.125, if you rounded wrong, so just be careful and pay attention to the details. Waiting to catch up here. All right, part 3. So these are 4-pointers. Going to be a little bit more work to do this one. Triangle ABC is shown below. Use a compass and a straight edge to construct a dilation centered at B with a scale factor of 2. So what we're going to do is we're going to take our compass, okay? We're going to put the sharp point at B. Before we begin, we are going to extend the line away from B, going out, okay? And then away from, on BC, away from C here, going out as well. And then we're going to take our compass. Let's see if we can pull up the compass here. All right. And then we're going to measure the distance from A to B, and then we're just going to double the distance. So swing an arc, sharp point at B, mark off A, double that distance to find A prime, and then do the same thing here. Measure C, double that distance, so drag it down the line, and then we're going to mark that off. And then make sure it says dilation of ABC. So you just have to make sure you connect those 2 points with the line when you're done. You don't have to label it, you just have to connect it. All right, and then it says, is the image similar? And then you're going to explain why. So let's do the explanation first while this loads. So in the explanation, we're going to say yes, by the way. Okay, remember the dilation is going to change the side length. In this case, it's going to double them. We'll say doubling the length. And the angles are going to stay congruent, or will stay congruent. All right, so that would be enough. As long as you're mentioning the fact that the dilation is going to produce a triangle that has the same side lengths that have been multiplied by the same number. And then we're going menu, tools, compass. There we go. So compass on B, pencil on C. Slide it out. Mark it off. All right. Back over to B, pencil on A. You don't necessarily have to mark off, but you can here if you want to indicate that you've measured that. And there's our length. And the last thing we want to do then is just connect those two with a line. I think we just broke something. Let's try that again. Oh no. And there's our answer. Okay? So that would be full credit. I'm just going to clip this so I can paste it in there later when we're done. All right. Let's get rid of you so we don't eat up all the memory here. Let's paste you over there. Okay. 33, prove that the triangles are congruent. So we know in the triangles below, here's what we know, okay, that these two triangles ABE, all right, and we know that triangle DCB or CBD, these two triangles, we know that they're congruent. So next thing we want to focus on is what two triangles are shown are congruent. We want to show that angle AFD okay, and triangle CFE are equal. Now, think about it when you're doing it this way. How do these two triangles help us out? What parts of these triangles are the same in these triangles? And also, if we're just trying to show that these two triangles are equal, okay, just these two triangles here in purple, what else can we see is going to be equal right from the diagram? Okay, that's going to be key. All right, so a few things you can already see, hopefully, just by looking at them. I'm just going to retrace these. Number one, we have vertical angles here right away. So we can get this angle here, all right, equal to this angle right there. Number two, in these two big triangles, notice that I'm tracing right over angle FCE again when I do FCB or DCB. So this angle is part of that triangle, okay? And it's going to be congruent to this angle over here. And then number three, this side length right here, okay, is going to be congruent to this side length down here. We'll put a little mark on those. And this entire side here is equal to this entire side over here. So, if we just subtract these two sides, we're going to get left with this guy right there. And if we subtract these two sides, we're going to get left with this side right here. That's all you're going to need to do to make this proof happen. Okay? Waiting for the craziness on my end down here. All right, so let's do it. We're going to do our T-chart. Okay? Build our statements and reasons, and then we'll be good to go. All right. So, statements, reasons, and remember, this is a part 3 proof, so it's not going to be crazy difficult, a ton of steps. It might have a lot, not a bunch, not a ton. So we have triangle ADE congruent to triangle CBD. That was given. That's the only given we have. Step 2, we're going to use these two angles where A and C are. So angle A is congruent to angle C. Okay? And that is by CPCTC. Now, the other two things we want to use for CPCTC are the entire side length here. So that's AB. And then this entire side length, BC. And this smaller segment, BD. And this smaller segment, BE. Now, if you added more than one CPCTC step, like you added one for these, that's totally fine. Just as long as you have a statement, each one of those, or one big statement, putting them all together. Okay. So now what we're going to do is we're going to subtract these things. So since they're equal, we can use subtraction property of equality here. So we're going to start with AB, okay, equaling BC, and from both sides, we're going to take away this side over here, which is BD, and this side, which is BE. And that is the subtraction property of equality, because we took two things, we subtracted equal amounts from both sides. Okay? So subtraction property of equality. And then the last thing we got to do, two things we got to do. Number one, we got to end up with these two sides equal right here. So that's next. So AD is equal to FC. And you can either use substitution or segment addition, segment subtraction. We'll go with substitution here. When in doubt, substitution, okay? The last thing we need to do is do our vertical angles. So angle A, FD, congruent to angle C, oh, that's an E down here, isn't it? EC. That should be EC here. Okay. And then CFE. And then vertical angles are congruent. And then now we have enough, because of angle, side, to get the two triangles, triangle AFD, congruent to triangle CFE. And as long as you put down AAS, you are solid and getting full credit. Now, as long as you were able to get any one of these things equal, vertical angles equal, that's a point. Okay? All right? If you're able to get 2 to 3 statements, you might be able to get 2 points, and then finishing the whole thing off, you're good to go. All right? 34. The other 4-pointer here. Cargo trailer picture will be modeled by a rectangular prism and a triangular prism. Inside the trailer, the rectangular prism measures 6 feet wide and 10 feet long. The walls of the triangular prism each measure 4 feet wide inside the trailer. The diagram below is of the floor. The inside height of the trailer is 6.5 feet. So keep that in mind, that is referring to like this height right there. What is the total volume inside the trailer to the nearest cubic foot? Okay, so not too bad, actually. So we can really make use of this rectangular prism here pretty easily, okay? So if you think about this as being our inside part, it's just the area of the base times the height, which we know is 6.5 feet. Okay, so the volume, we'll write for the prism, volume of P is just length times width times height. So that's 10 times 6 times 6.5. Nice and easy on that one. So that's 390. And that's now feet cubed. Okay. However, this part is going to be a little bit tougher. So keep that in mind, that this part is going to be a little bit tougher to do. Because, right, in order to do triangular prism, we need the area of, we need to do base times height, 1/2 base times height. So I'm just going to undo all the red stuff I just made. And we're just going to look at the bottom triangles here, okay? So this is the base, okay? The side of the triangle here. We're about to freak out again on my end, so just give me a second. That whole side. So you're going to have to do the whole side length here, okay? All right? And then we need the height is the distance coming out of it. We don't know that, though. But keep in mind that we do know a couple things. We know that this opposite side over here, because it's a rectangle, is going to be the same as this, right? Which is our opposite side, which is the height of this shape. Oh, I'm freaking out again over here. What is going on with this thing? All right. So this side is going to be 6. We're going to cut it in half by drawing the height in because it's isosceles. So really, we're looking at this right triangle here with sides of 3, right? And a hypotenuse of 4, and we need to get this side right here. So if we're doing Pythagorean Theorem, we're going to do c squared minus b squared equals a squared, or a squared plus b squared. It's up to you. We're plugging in the 4 for the hypotenuse. Okay. The 3 for the leg here. Keep in mind, it's not a 3, 4, 5, because the 5 should be the hypotenuse here. So we got 16 minus 9, and that is going to be 7. So the square root of 7 is actually going to be the length of c, and that is the height. It's the square root of 7. Okay, so now we can figure out what the volume of that triangular prism is, because it's 1/2, right? It's the area of the base times the height. The base is a triangle, so 1/2 the base times the height, and then times the height of the entire prism, which is, once again, 6.5. So it should be 1/2 the base, which is 6. Okay, the height is, which is the square root of 7, and then times the 6.5. And all we have to do now is add those two together, and we'll have our answer. I'm going to be right back. I got to go grab my charger real quick, which is right here. Plug in. Take over, Kate.
I don't know what to do.
Just say hi.
Hi, bye.
Tell them about your day. All right. So, calculator time. So half of 6 is really 3, but half times 6 times the square root of 7 times, make sure you get outside that radical, so hit the right arrow, 6.5. So it's 51.592. And then remember, we're adding that answer, right, to that 390. So up arrow, grab the 390, add onto it, and we have our answer. And then we're just rounding to the nearest, what do we got? Cubic foot. So we can actually round this one right away. So this is 51.592. And then the total volume, VOLUME, is 390 plus 51.592. And we know that we're getting approximately 442 cubic feet. Okay, and that's it. We're done with that question. So a little bit kind of hard just because you had to get that height there for that one. All right, now last question. This is a 6-pointer, so it's going to be a little bit tougher to do. Not crazy tough, but keep in mind we want to get the coordinates of D, so it's a square, and then prove it's a square down below. So I'm going to bring this back up again. Thanks for sticking with me. You guys want to head out on your own, do your thing, go ahead. Or if getting too late and you guys want to go take a break or anything, feel free. I'll post a video later.
Or if you want to go home and take a break from school.
Well, they're not at school, Kate. They're at home. All right. So let's start by graphing. So point 1, 2 is A. -5. 3 is B. C is -6, -3. All right. We want to figure out where this goes. Now, it's important that you look at the name of the shape. It's A, B, C, D. So D has to be down here because it has to go in that order. Okay. Now, keep in mind that you're going to use your slopes to figure this out. So to get from B to C, right, we're going to go up, how many here? 1, 2, 3, 4, 5, 6, and over 1. So if we move the same move, or we're going to go left 1, right, and then down 6, we're going to do the same thing from here. We're going to go left 1, and we're going to go down 6. So 1, 1, 2, 3, 4, 5, 6. That point right there, that's where point D goes. That's it. Okay? Opposite sides have to be parallel. So if this line has a slope of 1/6, that's going to have a slope of 1/6. Or 6/1, whatever we're dealing with here. But left 1, down 6. Okay? We got to write that point down. So we're going to say point D. So D is the point 0, -4. And now we have to do a square. Okay. Now I'm just going to go off to the side first and draw these for myself. And the reason I got rid of that red line is because I want to redraw the rise and the run outside part here. Okay, remember to show it's a square, we have two options. We can get all right angles with two sides that are equal, okay, that are next to each other, or we can get all the sides equal and get one right angle. That's it, okay? So I'm going to go with the sides equal and then with a one right angle. But whatever you want to do, you can do. So I'm going to go around and do my rise over run from outside. You can count, it's going to be 6 and then 1. Here, once again, is 1 going over 1, 2, 3, 4, 5, 6. And then we're going over 6 this way and down 1. So since all the sides, all the rises and runs are all 1 and a 6, and all these triangles have the same length, I only have to do the Pythagorean theorem once. But I still want to say, when I'm done, the distance of AB is. The distance of AD is. The distance of BC is. And the distance of CD is. I still want to tell you what it is when I'm done, okay? So that's important. So 1 squared plus 6 squared is equal to C squared. This is 1 plus 36, which is 37. And so the square root of 37 is equal to C. And so I'm going to put the square root of 37 after all of these little distances that I wrote down. Or if you wanted to say all sides have a length of 37, that's also okay. Okay, now I'm going to go ahead and state the slopes. So the slope of AB is up 1 and then left 6. So that's 1 over -6. The line that's parallel to that one is CD. It's down 1 and right 6. So this is also -1 over 6. That's CD. The slope of CB is up 6 and over 1 to the right. And the slope of AD, or the line that's parallel to it, is AB is up 1. Right, we did that one already. AD, there we go, is down 6 and left 1, which is still 6 over 1. Okay? So we're good to go. So now I can say, okay, something about this work. We're going to say AB is equal or congruent to AD, which is congruent to BC, which is congruent to CD, because the distances are equal. Okay, now over here we're going to say that AB is perpendicular to AD. Slopes are opposite reciprocals, or negative reciprocals if you want to say that. And I have enough. Okay? So, ABCD is a square because all sides are congruent and all angles are 90 degrees. You can even just say that there's a 90-degree angle. Okay? And we're done. That's it. That's all we have to do. We mentioned the slopes are opposite reciprocals right here, so we don't have to say that again. We mentioned that the distances were equal. We don't have to say it again. Okay? So we're good to go. That's your proof. Congratulations on crushing and getting 100s. All right? Thank you for staying with me there. I'm going to end this.